Hello.
Hi, Mr. Kean.
How are you?
I'm good. How are you?
Pretty good.
Yeah. Yeah. I hope you're having a great weekend. Thanks for joining the interview. I'm really
No
excited
worries.
with you
No
today.
worries.
So, just a quick intro on me. I'm Ritik Raya, a current eighth grader who attends Pineview School for the Gifted, which is one of the top three public schools in Florida. And
Okay.
I'm a voracious reader, and I play guitar in my free time, and I love traveling. And I love reading books on political science, and I aspire to become a neurosurgeon. So,
Oh, very cool. Okay.
that's pretty much me.
Okay.
And I did some research work for this interview, and I came to know that you've earned the title of being a New York Times bestselling author, which is amazing. And I saw four of your books were all Amazon's top science books of the year, which is also very cool. So, as we can tell, you are an accomplished man in the field of science. Besides all of these accomplishments, I wanted to know you as a person and your thought process on approaching the book, hoping that would be a good start, Mr. Keene.
Okay. Sounds good.
Okay. So, which authors or books have influenced you the most, you think?
Um, so I was a double major in college. I was a physics major and an English major. So I obviously for the English major read a lot of literature and things like that. So I have a pretty broad background in literature and I just enjoyed, reading classic novels, contemporary novels, things like that. So when I realized I wanted to write nonfiction, I did want to incorporate the things that fiction writers do. So I try to draw pretty widely. I do have some favorite authors. David Foster Wallace is one. Neil Stephenson's another. He writes fiction. Um, and some favorite books like Making of the Atomic Bomb is one that pops out. A Guinea Pig's History of Biology is another, and some others. With those authors, though, they have such distinct voices that I feel like you can do a bad impression of them if you're not careful. So for me, it was more just picking up the techniques they were using, dialogue, how to set a scene, build suspense, things like that, rather than the voice that I was kind of looking for.
Well, I don't think I've read those books, but you definitely did a great job in writing your own.
Thank you.
So, when did you first realize you wanted to be a writer? Because you definitely studied like English in college. So, did it happen before then, or like?
It was later. I picked up the English major after I decided I wanted to write. So I was a science major and very focused on being a scientist till about 3 years or so in, and I started working in labs, science labs, physics labs, and I realized I just hated the work. I did not like being there. It was not enjoyable at all. And I just realized I didn't want to do that for the rest of my life, be in a lab doing that kind of stuff. So but at the same time, I did like science. I liked the field of science, wanted to keep involved with it in some way. And writing about it was a good way to keep abreast of the field, learn about science, but without having to be in a lab and specialize the way you do in science.
That's great. Yeah. So, how did you approach the research for this book? Because you definitely mentioned like this V.S. Ramachandran guy, and I read his book, The Telltale Brain, which
Mhm.
was also very good. So, like, did you just read lots of science, or did you like have connections which told you which like books or articles to read for your books?
Mostly reading in this case. Some of it was more popular work, like the Ramchandran book, or Oliver Sacks is another name drawing on those. A lot of it, though, was just going to the actual neuroscience, the published peer-reviewed papers, and reading them, and the neurology papers. And actually, it wasn't as bad as I was fearing. I didn't have a background in neuroscience, so I was a little at a disadvantage there, but neurology, neurology papers especially are fairly approachable because you're dealing with things like emotions and memory and language, things that we're all familiar with, at least on some level.
Yes.
Whereas if I had, tried to jump into physics and started reading physics papers, those are very dense, very complicated. There's no way a layperson could just jump right in and start reading those papers. So it was lucky in that I picked a field where a layperson with a little effort, there's some jargon and things that you gotta figure out, but with some effort, you can get through those papers.
Definitely.
Yeah.
Okay. So when you hit writer's block, did you have like a secret weapon, like a cup of coffee or a nap? Or like, what did you do?
Um, I had a teacher tell me something once that I think was pretty smart and pretty a good way to get around writer's block. She pointed out that there's often two different types of writer's block. There's one where you don't know what to say. And often, at least with nonfiction, the problem is you haven't done enough research. So if you're really stuck on something, you probably need to go back to the sources or pick up additional sources, call someone up, figure out what you're missing, and that will usually help you get through it. So that's one kind when you don't have enough information. Another kind is that you kind of have too much information and there's just so much you want to say and you don't know how to get it all out. And the solution there, I think, is to just start writing as fast as you can. Don't worry about having a perfect introduction. Just get the sentences on the page. Once they're all on the page, even if they're not full sentences, you can rearrange. It's much easier to rearrange than it is trying to juggle everything in your head. So getting it out on the page, just kind of spew it out there, I think is a good trick for that.
Okay, thank you. So how long did it take you to write the book from like concept to publication?
This is about 2 years or so, and that was the case for most of my books for about 2 years. I have a new one coming out this summer. It's actually been about 4.5 years for that one, just
Oh,
because
so
there was a lot of
later.
travel. Yeah, it's been a while, but that one was a lot of travel, and then COVID, the pandemic happened, so actually more like 5 years. The pandemic obviously couldn't travel or do much, so that kind of delayed the process with that book.
Okay. And if you could collaborate with any other author, who would it be and why?
I hadn't thought about that. I I don't know. There's a couple I can think of. A couple science writers who are working nowadays that I really like. Carl Zimmer is a great one. Amy Stewart, Deborah Bloom are some people who come to mind. I don't know that I don't. I think I work pretty independently though. I don't know how much I would enjoy a collaboration, even with great writers like them. I just like doing it myself, and maybe they're the same way. I don't know how much they would enjoy it either. So.
Okay. Well, those are all interesting answers, and I feel like I've heard of the last two authors, Deborah Bloom and Amy Stewart, before,
Mm.
and I might have read one of their works. And yeah, I feel like being independent as an author is like its own satisfaction too. I feel like it would grant you that. Yeah, definitely. So, as someone who's deeply interested in neuroscience, I was like fascinated by the way that your book explained how the brain worked and how historical cases have shaped our like present knowledge. So, I'd love to ask you some questions that like dive deeper into the biology and like science behind the stories.
Okay.
Okay. So, just a little background for the people watching who don't know this. King Henry II died after a jousting tournament after suffering from a brain abscess, which is like a collection of pus and other materials in your brain caused by an infection. And it showed how limited our understanding of brain trauma was in the 1500s. So, Mr. Kean, was there a reason Ambroise Paré, like the royal surgeon, refused to perform the emergency surgery, which might have saved the king?
I'm having to think back on this now. I believe I believe the king's advisors did not want him to do that, and he was a little nervous about it, given that he wasn't. I mean, it was the king, and he didn't want to, try something sort of radical on a king, given that, the consequences of potentially killing the king were going to be pretty bad.
Yeah.
Um, it's been a while since I did the research for that, but that's what I'm remembering, something like that happening.
Okay.
Yeah.
So next question. Paul Broca was like the 1800s French physician who studied patients with speech difficulties,
Mhm.
and like he had a patient. I think it like his nickname was Tan because he could only say Tan,
Mhm.
but he understood language. And through his autopsy, Broca found damage to a specific area in the left frontal lobe, which I think is now called Broca's area. So do you think Broca's discovery of Broca's area had a bigger impact on understanding how we produce speech or identifying specific functions in like areas of the brain?
I think it was both. It was a specific discovery in that because that area was damaged, on this side, left side, because that area was damaged, he was able to show some pretty convincing evidence that that was that is why Tan had the speech deficit, was because of damage to that area. It also, in a wider sense, gave credence to the idea that the brain has specialized regions
Yep.
and really help that theory along. So I think there was sort of it's both kind of the forest and the trees. The trees was he got some detail evidence on speech production, but then it lent credence to the wider kind of bigger picture idea about brain specialization in general.
That's a great analogy. Yes. And next question. HM was a patient who underwent surgery to remove his hippocampus because, like,
Mhm.
I believe he was suffering from severe epilepsy. And he could form short-term memories, but was unable to create like new long-term memories. So why do you think his case was like such a turning point in understanding the relationship between short-term and long-term memory?
A few reasons. One was that the damage that induced by surgery, so damage maybe isn't the right word, but the deficit that he had when he had his hippocampi removed was so clean and specific. Sometimes with an infection or an injury, it's kind of messy. There's a lot of areas that get hurt, but this was a surgery. They went in and they just took out those two areas. The other thing was he was under observation for so long and participated in these tests for so long that we got, 30, 40 years of data, something like that. I think even longer, like a half century of data from him. So the fact that we had so many years working with him, we knew specifically what parts had been removed and just how stark his deficit was because it was so memorable and it became it's an easy, vivid story to remember.
Okay. That's very interesting actually. So next question. Phantom limb syndrome occurs when like an individual who lost like a limb, like an arm or leg, continues
Mhm.
to feel sensations like pain in the missing limb. And it's linked to, I believe, the somatosensory cortex, where the brain maps sensory input.
Mhm.
And so research into some of your cases like revealed that the brain has the ability to adapt like neuroplasticity. So what cases of phantom limb syndrome teach us how the brain like adapts and interprets the body better?
So this arose, a lot of this stuff arose during the Civil War, the US Civil War, because of new types of bullets and guns
Yep.
that appeared then. And so that was the first time they had a widespread number of cases, lots of cases to look at. It was anecdotal evidence before, but people, I think, kind of dismissed it as a one-off thing. Civil War, finally, they had, thousands of cases probably where they could just get data over and over and show that this was not an anomaly or something weird or someone, fabricating a story. This was really true. But yeah, it's when the somatosensory cortex is still sending out input and expecting input, and in some cases feeling input, but there's no actual input there. And in some cases, the brain sort of gets in a loop where the information is just coming in. And if they actually had the limb and they could use it and do something, it would sort of break that, like sort of pop that bubble that's doing that in their mind. But because it's not there, it's not getting any input and they can't break the cycle, essentially. And the Ramachandran book you mentioned, I think I mentioned this case in my book. He developed a really interesting way of kind of breaking that cycle, which was to have people essentially look in a mirror. If they are missing one hand, they can use their other hand to look in a mirror so that it looks like their other hand. And the sight of that, humans have very strong sense of vision. So the sight of that would override the sensory, like the tactile
Yep.
loops in the brain and kind of move them past that. So.
Okay. Yeah. I remembered that too. Like he had a whole section on phantom pain and
Mhm.
like he wrote very extensively on that. Yeah, it was
Yep.
a great book. So another question. Phineas Gage, he was a railroad worker who suffered an accident where tamping iron damaged his prefrontal cortex, causing dramatic changes in his personality. Like before the injury, he was responsible and sociable, but after he became impulsive and struggled with planning and like money decision making.
Mhm.
So, what does his injury reveal about how like the prefrontal cortex affects personality and emotional control?
I think the important part of his case was the fact that they were able to pin personality, or to say that there is a part of the brain that controls personality. There's a physical substance in our brain that if it's damaged, your personality can change afterward. And that was not something that people accepted before that. I think there was a much more widespread sense that, the soul, whatever it meant, was sort of what defined us and gave us personality, as opposed to a piece of physical matter in our brain. So the damage that he suffered to his frontal lobe really kind of crystallized that idea that our brain is what produces the physical organ is what produces our personality. The other thing I think that Phineas Gage teaches us is sort of about scientific myth making, because you often see in textbooks, especially, anecdotes about him that after his accident, he became a drunk or a criminal, or, he was doing all these terrible things. And there's really not good evidence for that. It was just a myth that got passed down from generation to generation. But so we know he did change. That is true, but not in the drastic, horrible way that a lot of you see it often in textbooks again. And even the things that you mentioned about, money and stuff like that, he did go down to Chile afterward and was driving a horse coach, a stagecoach down there, and must have been, handling money and doing some job. So it's not like he was just magically okay and the same afterward, but he was again able to rehabilitate himself a little bit, it seems, and hold down a job for quite a while, which is pretty remarkable for someone who suffered such extensive brain damage.
So, like the reason for his popularity is like kind of like a myth. Like he wasn't actually suffering that drastic of a change.
Yeah, he does deserve to be well known, much like the case of HM, in that it's such a vivid, interesting story. But the details of it have been exaggerated and stretched beyond the truth.
Okay, thank you. So, I thought we could talk more about like the future of neuroscience next. So, like early neuroscience relied heavily on autopsies to understand brain function, like often mapping damaged areas to specific behaviors or deficits. But today we have like fMRI and PET scans, which allow scientists to observe brain activity in real time. So this revolutionized our understanding of the living brain. So how do the modern imaging techniques like fMRI scans expand our understanding of the brain compared to like earlier methods like autopsies?
Yeah, I think the basic thing is that we can see, as you said, we can see things going on in real time. And we can also see how the normal brain works. The injuries I talk about in the book were very important for figuring out essentially what every part of the brain was. That was the first 4 centuries of neuroscience, was just waiting for people to get injured and figuring out what the brain did based on that. But you could always make the argument that you're observing someone with a damaged brain. And so was that reflective of how a normal brain worked, an everyday uninjured brain? And because of MRIs and other scanning technology, we can now see how human brain works an undamaged brain works in real time. I do think we will need to I don't know if it's just that we don't have the computing power yet, or we're kind of missing something about the brain, but I think we will need sort of it's a cliche, but like a paradigm shift and a deeper understanding of connections in the brain or something like that to really move on to a deeper understanding of the big questions like, what is consciousness, a sense of self? How does memory work on a deep level? Like, how do you go from a series of cells firing off little chemicals to being able to imagine something in your mind? There's a big gulf there, and it's not clear to me. I don't know if it's clear to anyone whether we just can keep scaling with what we're doing and we'll finally get there, or if we need to take some sort of leap and have a new conception of how the brain works. So I think that's the big question in neuroscience right now is whether, yeah, again, whether we just can keep going and we get there, or there's just going to be some sort of shift.
That's actually very insightful. Thank you. So the brain, the book emphasizes that the brain is like resilient but also fragile. So
Mhm.
which case do you think is like best to highlight the brain's capacity to adapt after injury?
I think the fragility is important just because, it helps us protect our brain. We take care of it. I am obviously older and I remember, back like football players and things, they would get concussions and then you were considered weak if you didn't go right back out there after a concussion. So I think we have a much better sense of the fragility of the brain and the need to take care of it and not suffer another concussion or, expose yourself to damage like that. But at the same time, it is important to know that the damage that you suffer isn't necessarily permanent. Sometimes it is, but you can, in some cases, rehabilitate and recover at
Like,
least some function or figure a workaround or something like that.
okay. Is there like a specific case from the book that like exemplifies that?
Um, I'm trying to think. I think Phineas Gage probably is a maybe the best example of that. Again, given how extensive and how dramatic his injury was, the fact that he was able to go to a completely different country on his own, get a job there, work there for 7 or 8 years. Eventually, his brain damage did catch up with him. He started suffering seizures, ended up dying from that. But he lived a pretty good, remarkable life. And his case is also good because it shows. So his job as a stagecoach driver was essentially pick people up at point A, go to point B, and then B to A. He did the same thing over and over. So he got a job and was doing tasks that he was able to handle. If he had just been, like a guide leading someone off into the woods, and a more open-ended task, he might have struggled with that. But because he figured out and put himself in a situation where his limitations weren't as exposed, he was able to thrive at that. So I think I mean, that's even a good general lesson for people, figure out what you're good at, figure out how you can exploit your own talents, and put yourself in those situations to succeed.
Okay. Thank you. So the idea of plasticity comes up often in your book. So which case do you think like best demonstrates the brain's ability to rewire itself after trauma or injury?
There are a few cases I talk about language production where people have suffered injuries to Broca's area. Excuse me, not to Broca's area, to the connections between Broca's area and the mouth. So the nerves and the neurons that are bringing information down. But these people had back alleys in their brain, so they can sing song lyrics, for instance, even though they can't speak in an everyday conversation like we're having right now. They can sing song lyrics. But by practicing with song lyrics, slowing down, bringing some of the musicality out of it, they were able to rehabilitate their speaking and use other parts of the brain, recruit other parts of the brain in order to produce everyday speech. So that's a good example of plasticity there. People who lost the ability to speak, but they had other abilities like singing song lyrics and were able to recruit those areas to regain the speech function that they'd lost.
Okay. Uh, so like as someone who wants to be a neurosurgeon, I was struck by the balance between historical limitations and the breakthroughs in your book.
Mhm.
So, what lessons from these early cases do you think are most relevant for like aspiring scientists and doctors today?
One thing that struck me about the book is that there's a lot of cycles in the history of science, and in my other books as well. Ideas come back around; they go back around. So localization, for instance, um, in Broca's time, after Broca's time, and because of Broca, there was an emphasis on specialization in that each part of the brain had a specific function, and this was the language spot, and this was the spot to do this. This is the spot to do this. And we've since gotten away from that and moved into a better, more holistic understanding of, language production involves many different parts of the brain. There's a lot going on there. So there are loops and other things that work to produce language. It's not just one specific spot. But sometimes nowadays people take that too far and they say, well, there's no specialization in the brain at all, which I don't think is true. There is some specialization. So you see ideas like this, there's an ebb and flow to them. And some ideas, they come back around, they come back into fashion. So I think that's a good reason to learn about the history of a field is that you can see the bigger picture, learn about debates in the past that could shed light on blind spots and assumptions that we're making nowadays and figure out, yeah, again, blind spots and where we're um, taking things for granted or not seeing things in the proper light because we don't have the perspective.
Okay. So, if you could update your book with a modern case that illustrates like a major discovery about the brain, which case would you choose and why?
Ooh, I don't know off the top of my head. I'm sure I could add some more about the genetics and the scanning technology. Um, there's probably some other cases, but they are not coming to mind right now. So I would have to think about that.
Okay. Well, thank you so much, Mr. Kean, for sharing your time and insights with me today.
Okay, my
Before
pleasure.
I wrap up, if there is one thing you want readers to take away from your book, what would it be?
I I think what we talked about before about the resiliency of the brain. And these stories, in a lot of ways, are very dramatic and startling because you see people who are losing skills that are just so specific. And it just seems like their life is so strange when they suddenly can't recognize anyone's face or they can't sense motion anymore, things like that. But people are pretty resilient and they figure out ways to get around those things. Either they come up with workarounds or the brain kind of rewires itself. People are pretty resourceful and clever. And I think that is a good message of hope in the book. I didn't want it to be just here's something weird that happened to one person. Here's something weird that happened to another person. I think there is a bigger message of hope in the book.
Okay, awesome. Um, it's been a pleasure getting to know more about your writing process and the inspiration behind your book.
Hmm.
And it's been so inspiring hearing about the entire process of writing your book. I'm sure many aspiring authors will find your insights invaluable. Thank you so much for taking time to do this with me. I truly appreciate it. And I hope you have a great rest of your weekend.
Okay, well, thank you very much.
Thank you.
And I'd mentioned the possibility of a talk down there. If yeah, just let me know how that's going, or if anyone has any questions, if any teachers, administrators want to get in touch with me, you have my email address, so feel free to pass it on.
Okay, thank you.
Okay, sounds good. Thank you. Have a good day.